There we go. Okay, so let's go over everything you got for this week. This is week 4. Exciting. So we're going to do 4-1, 4-3, and I think, Cindy, didn't you say you deleted this one? Or no?
I did not delete it. A lot of people turned it in last week because we
questions today.
I deleted the 3.4.
Oh, gotcha. Okay, gotcha. So these are the 3 for
me, and then if you pull down, you can see yours.
And this stuff we're covering this week in class. So these are the notes for this week. This is not working. Notes tomorrow and Thursday. So for my class, we have a 3-4 worksheet number 2. That's what we're doing today. And we'll probably do this 1-2 worksheet today. And we will look at this one today. And we will maybe give you some time to work on this one. So this is today. And then on Thursday, we'll be doing, or Wednesday. Why don't I use M's and W's? Wouldn't that make a lot of sense? So M, and M. We're putting chapter 3 to rest today. And then Wednesday, we will be seeing how far we get on chapter 4. And if we don't get through all of chapter 4 on Wednesday, that's okay too. So if there aren't, let's see, are there any questions? You were bringing a worksheet today that you would have completed. Does anyone have any questions on those worksheets, on that worksheet, or any worksheet? Doesn't matter.
I emailed you 2 worksheets because I couldn't resubmit them through Canvas.
Got it.
Or through MSO.
Yes, I saw those.
Okay.
I sent you an email back, and all it said was, Peg, received. Cheers, Eric.
Oh, I guess I have it. Awesome.
I sent it this morning. Cool. I sent it this morning.
Awesome. That will be a surprise. I'll just pretend it's a surprise.
Nice. Sorry.
Okay. So, yeah, I'm fine. Okay. I didn't print out 1.2 worksheet, but I'll just work it online. That's cool.
Sounds good. All right.
Yes, I've got the whole thing down now.
Nice. Well, let's start with 3-4 then. So I should be saving the write-ups. So we ended class last week with an overview of 3-4 and 3-5. Remember, that's we're looking at position for 3-4 and 3-5. Measures of position, and we had the 3 measures: z-score, percentile, and quartile.
Mm-hmm.
So we're just as a quick reminder, you need this for this first page that we're working on. This is the z-score formula, is the data value, whatever is provided to you. We hand this to you, and then subtract the mean from it and divide it by the standard deviation. Be careful if you're using a calculator that doesn't allow fractions or things. You need this to have happened first before you divide. So if you feel like you're good, let's do this. Start here. And let me do what I've been doing, where we practice reading the problem. I don't think that ever gets old. So let's see. Oh, by the way, everyone, we're on page 508 of your course pack. And this is where, if you have an old course pack, I'm like 90% sure that these are different numbers. I think this is a totally different problem than what used to be on there. So in 2017, a pollution index was calculated for a sample of cities in the western and eastern states and US using data on air and water pollution. That's a lot of context, but we did get one word here that tells us what symbols to use on the information we get. And we also know the like the numbers we're getting, right? It's a pollution index, whatever that is. So the eastern cities had a mean of 35.9 points. That means the X bar, I'm going to use a lowercase e for eastern, had this mean. And notice the units on this are points, whatever those are. And then with a, here's another special word, standard deviation. We know the symbol for sample standard deviation is S. I'm putting a subscript E for Eastern so that we can keep track between which one's Western, which one's Eastern. This one had 11.6 points. All right, so all we've gotten from the first two sentences is that we're working with sample data and we know the mean and standard deviation for the Eastern states. And then here comes the Western states. They have a mean of 43.0. I'm going to both change colors and subscripts. So the symbol for sample mean, of course, is X bar. I'm going to use W for Western, and this is 43.0 points. And a standard deviation of 11.3 points. So S subscript W, 11.3 points. Okay, awesome. Now we get a little more context. Higher scores mean more pollution, which apparently we don't want. And then we are to assume the distributions of population indices, I think they should say are approximately normal or approximately bell-shaped. And remember what this tells us. This tells us that z-scores are appropriate, like they make sense when we calculate them. They tell us useful information. If it wasn't approximately bell-shaped, any z-score we calculated wouldn't be particularly meaningful. It also tells us that the center of these distributions are these sample means. So we could use the empirical rule if we wanted to. All right, so we haven't got a question, but we have a lot of information in that first paragraph. And then if you check out what A says, we got Detroit, Michigan. We're told where it's located. It's in the east, meaning we're going to use this information. And it had a pollution index score of 56.2. Notice it's giving us a score, meaning this is a data value. Your textbook used the notation of X. Like we could say X subscript E equals 56.2.
Can I just stop? Can I stop you right here?
Please.
Can you please just go over the X bar and the values just one more time, really slow, before we move on, because I was trying to keep up with you and then I lost you. So just
definitely,
and I mean, just make a brief overview, because if I go any further, then I'm going to completely lose, and that's not good. So
remember, X bar specifically or generally means sample mean. And then S generally means sample standard deviation. So those are just the symbols that go with the sample mean, sample standard deviation.
Okay, so you're just putting the points in the word problem that we're reading. You're just putting them where they fit into the symbols. Okay,
that's right.
Okay, got it.
And the reason for that, I'm glad you asked, Peg. The reason for that is it's easier, in my opinion, to read the information here than to have to keep reading through the paragraph for those particular things. Because if you look here, we're given a score for the East, and it says calculate that z-score. Well, we need to know what was the sample mean for the Eastern states. Well, it's right here, as opposed to digging back in there.
Right.
And then down here, it says, here's Salt Lake City. It's in the West. Here's its index score. Calculate its z-score. Well, again, my argument here is that because I've written these here, it's easier to do this calculation than reading it. Cool. Well, that was actually where I was going to stop. And I was going to say, do it. If you're forgetting, here is the z-score formula. Hopefully you have that in your reference sheet somewhere. It is, oops, I didn't mean to go there. it is buried in your provided reference sheet. I think it's going to be better if you just write this z-score formula in your own reference sheet. Well, maybe actually, let me double check. Let's go to the appendices and let's see how it's provided for you. It is not.
Yeah, I was going to say it's not given.
It's buried. It used to be buried somewhere in here. Yeah, it's not easily given anywhere. It's not given, period. It used to be sort of buried, but it's not. So you'll want that in your personal handwritten, or however you're preparing your reference sheet thing. So let me give you, let's say let's do 10 minutes and see how far on this first page you can get. See if you can't do the whole thing. Oh, remember we did the one other thing I didn't, I'm sorry, I'm clicking all over the place. The other thing is we solved this for the data value. I'll rewrite that one. It's probably somewhere in your notes from last time. Oh no, I don't, maybe I didn't do it for this class. And that is, if you're trying to solve for the data value, when you know the z-score and the mean and the standard deviation, you would do this. Take whatever the z-score is, if you could spell it right, multiply it by the standard deviation, and add to it the mean, and then you can calculate a particular data value. So these are the two sort of formula things you need to calculate, and you're ready to go. We did do a reference sheet thing right at the end of class on Thursday, and I need to start saving these when I make them, but I don't think I saved it.
Do we use the data value, that one, do we use that for A and B or just the last two?
This one, you only need this data value formula for the very last one. Here it says
just the last one.
Yeah.
Okay, got it.
You could use it here if you wanted to. You could do the calculation. You don't have to. So 10 minutes, let's see how far you get. If you get stuck on anything, don't be afraid to ask us, and we will jump in and troubleshoot. Set a timer for 10 minutes.
10 minutes, counting down.
Oh, we're counting down.
So Emily, they're just working on page 1. On page, well, it's not page 1, it's page 580. 508.
508. Yeah, sorry, Emily, I should have.
She just came back on.
Okay, y'all, that was 10 minutes. How we doing? Anyone need more time? Anyone got stuck on anything?
I'm stuck on a little bit of everything, but I think it's because I missed Thursday last week. So I'm trying to look through my notes that don't have any notes to figure out what helpful, to do.
Isn't it? Well, let me write out A and you all see if you got it right. So based on the formula, we would take the data value, which is this, subtract from it the mean, which is this, and divide by the standard deviation, which is this. So for A, it's 56.2 minus 35.9 divided by 11.6. Now note, we are to give 2 decimal places. I really like Desmos for this. I'm hitting the division key. Actually, I'll show you me clicking it, shoop, and it creates a fraction, which is super nice. And then it's just 56.2 minus 35.7, was that? Nope, 35.9. Oops, that's not what I wanted to do. 35.9 divided by 11.6. And there is our answer. Nope, it's exactly 1.75. Does anyone remember what that 1.75 means? Or maybe I should step back and say, did everyone get 1.75? Yay. 1. Do y'all remember what that means? Go ahead, Laura, talk to me.
That's the only one I was able to figure out, but I think I understand now.
Good. Let me, quotes, interpret this in context, if that were something you were asked to say. This tells us that Detroit, Michigan is 1.75 standard deviations above the mean in terms of the eastern cities pollution index. Is this an unusual value? So like, is Detroit unusually polluted relative to all the other eastern states or eastern cities? And if you have no clue, that's cool too. We're going back to definitions from, well, 3.4, 3.2, I think is where we first encountered this. What does it mean to be unusual? What are the lines we draw?
When it's two or more standard deviations away.
Nice. Now I'm going to be super picky about the language. You're 100% correct. It's more than 2. If it's equal to 2, it's not unusual. That's that super picky. It turns out to be quite important, unfortunately. That particular or more. So, Reagan nailed it. Awesome. Is this unusual then? Let's answer the question, even though it's not on here. I'm just making one up. Is Detroit unusually polluted relative to all the other eastern cities?
Yes, because it's, or no, because it's more than or less than.
Perfect. Good. It's below the +2 standard deviations, so it's not unusually high. If it had been below -2, it would be unusually low, meaning way less polluted than all the other eastern city states. Excellent.
Did you just do like that math in your head to figure that out, or did I miss something?
I looked at 1.75 and said, it's less than 2.
But where did you get the 2 from?
From what you said.
Oh, got it.
Yeah, good. No, I'm glad you asked that question.
So the Z-score is like how many standard deviations it is away. Okay, got it.
Yes, that's the big point I'm wanting to drive home for you all, that the z-score is a measurement of standard deviations. Good. So that's, and notice the connections you had to make there. First, you had to know the definition of unusual. More than 2 standard deviations away from the mean, either above 2, below -2. You then had to know that z-scores are measurements of the amount of standard deviations a data value is away from the mean. And then connect those two, compare them. So not unusual is the take home here. Not unusual. All right, what z-score did you all get for B? Did you get 1.628? Let me make sure I got it right. 61.4 minus 43 divided by 11.3. Did you all get 1.63? Yay. Okay, good, good. Oh, sorry, I keep forgetting to watch the chat. Awesome. This one, we need the approximate symbol because we had to round it to 1.63. All right, and then do you all understand what we mean by absolute? Whose city has more pollution in absolute terms? In case you don't know what we mean by that, we mean just comparing the data values.
So you compare before taking the z-score.
Detroit has a 56.2 index. Salt Lake City has a 61.4. 61.4 is larger. So in terms of absolute difference, or which one is further, which one is a bigger number at Salt Lake City? Relative says, okay, compared to all other cities in these regions, which one has a higher pollution index? Or which one is more polluted? And there you're going to compare the z-scores because pollution in the east is, let's see, it's lower on average than pollution in the west.
So the absolute is the numbers that it's like the data value that it gives you before you do anything else. Okay, and then the relative is z-score.
Excellent. Yes, that's exactly it. Why am I writing relative? Yeah. That's an important distinction to make there. It's kind of weird, but keep writing relative. Z-score, it's Z-score. I don't know if this makes a lot of sense, as much sense in this context. The old problem we had was heights of like 2 athletes, one male, one female. And the male athlete was taller than the female. So they were absolutely taller, because if we measured them back to back, the male was taller, was taller. And that typically happens between male and female genders, right? But then when you compared the athletes to their gender, the female athlete in that problem had a larger z-score because they were taller compared to other women. So that's one thing that a z-score allows us to do, is to compare data values from different data sets that have different means and standard deviations. But when we convert them into z-scores, we can compare them directly in terms of which one is bigger within their pool of stuff. Maybe even a better option. Go ahead, Regan.
Well, will those, you'll always pick the bigger number? Does it depend on what the question's asking?
Yes, unless they're saying which one is less, then it would be the smaller number.
But when they say absolute and relative, you always just pick the bigger number.
If we say which one is more or larger.
Oh, okay.
So yeah, it depends on, yes, that's a good point. So absolute is comparing data values, and if we're saying which is the bigger data value or the smaller, then it's that relationship. Whereas relative is comparing the z-scores. The other example, are you all aware of the SAT versus ACT standardized tests? They have totally different scoring systems. Like I think a perfect score in the ACT is a 36, and the perfect score in an SAT is 2,400 or something, 3,200, something like that, something in there. And so if someone took an SAT and the other person took an ACT, we can't directly compare their scores because they're not in the same scale or anything. But if we convert them to Z-scores, we can see who did better. And that you did that in the notes, didn't you? I think that's the
yes.
note.
So you guys remember we did compare male and females heights, because remember we did what Ray, and we were doing those Star Wars characters in the notes. And then you guys were telling me things that that's not fair to compare, like shoe size and strength and that type of thing. You guys were telling me that it was not fair to compare those things.
Absolutely, right, is the language we use. Or you could say the word directly. I don't know. Okay, what'd y'all say for the San Antonio, Texas? It had a Z-score of 0. What does it mean? We could just calculate the data value. So it's the Z-score times the standard deviation, which Texas is a Western state, so that standard deviation is 11.3, plus the mean, which is 43. Look at what the data value is equal to. This is all 0. It's equal to the mean. And that's the whole point here. Anytime you have a Z-score that is 0, that means that data value was exactly equal to the mean. So the data value equals the mean. Okay, anyone have an answer for F? Anyone willing to admit they don't know how to do F, or did you all just not have enough time?
I didn't have enough time.
Okay, well, let's do 5 minutes. Set a timer for 5 minutes. Well, okay, let's check it out. Do we think it's 27? So you're just smashing it into this formula, right? We're going to take the z-score, multiply it times the standard deviation, add to it the mean. Negative 0.767. By the way, is this an unusual data value? Why do you all say it's unusual? Give me your explanation. Okay, love it. You all love it. You're all wrong. Because this 27 is a data value. And this is the z-score. And negative 0.767 is not less than -2. So this is not an unusual z-score. In fact, it's right in the 68% range of typical scores. Like it's really close to the mean is what that's saying. So be very careful. Oh, there's the 5 minutes. Be very careful with negative z-scores. That is a really common mistake. Students want to say, oh, it's unusual because it's negative. And you also talk to me.
Yeah, I just want to interrupt and go, yes, it's huge. It tripped me up so many times when I was doing z-scores. I wrote it down on top of that appendix that we're allowed to use the exam, really big. Watch negative z-scores. Larger negative z-scores are smaller scores.
Yeah, negatives are weird, right? Because like -2 is the threshold, and to be unusual, it's got to be like -2.7 or -3. If you have a by the way, if you were thinking this was the z-score, you should pause. It's possible you could have a really large z-score, but a z-score of 27 is just unimaginable. In fact, z-scores beyond +3 or -3 are also really uncommon. Remember, the definition of unusual is between -2 and 2, like outside those values. So if you do a calculation of a z-score and it is something crazy big or crazy small, you probably did something wrong. Not always. Well, Laura, if you look at the actual value, it's 27.0028. So technically we need the approximately because we dropped off the 0.0028 part, but I wouldn't be super picky about that. That's not all that important. Cool. Okay. Awesome, y'all. Great work. Let's keep going. Let's do some StatCrunch. Don't type this mess into StatCrunch. We can find it. So let's all log into our StatCrunches. I'm going to get there directly. By going to the StatCrunch website and signing in with my StatLab. If you're comfortable going to my StatLab and then getting from there, that's great. It doesn't particularly matter how you get there. And we're going to search for the name of this data set. So if you look, it says that this is called Superfund sites. So I'm just going to click the data sets from the homepage. I'm not going to open a worksheet. I'm going to go to data sets and I'm going to type in Superfund sites. And there's two options here. If you look at the last time they were edited, August 11, 2022, that's the one we're going to want to use. And here is the data set entered, already typed in for you, all 50 numbers.
Okay, hang on. Let us catch up.
I'm going to hang right there. And I'll leave this up so you can see what I typed in. I only had 3 cups of coffee, so I'm not blazing too fast today. Ooh, okay, Brianna. How shaky are your hands? The question is, did you get that high octane coffee or is it the low octane? I'll tell you, one time I got McDonald's coffee from the McDonald's really close to the Adrian campus, and I swear they put crack in it. I was like off my rocker after drinking that. I mean, it was like one of those, 2,000-ounce cups, but I was flying. Oh boy. Oh boy. That Red Bull is killing you, Laura. Don't drink it. Yes, it gives you wings.
She's not lying. I'm over here flying. It's good to go.
What's the heart rate? How we doing, everyone? Is everyone into the worksheet?
No, where am I going when I get onto super fun sites?
Clicking it and open it up to this. That's it.
Which one? The August 11th or July 3rd?
August 11th, because that's the most recent. They might actually be the same, but I don't know.
Okay, pull yours up again so I can see what it is. I have 3.4 WS2 super fun sites.
You got it.
0, 1, 2, 3. I think that's it. Yes, I'm there.
You got it. Awesome. Now I'm going to stop instructing you and you do this. Unless you're forgetting. Can you find the mean, the standard deviation? Oh, by the way, note this, treating these data as a population, just a reminder, that messes what standard deviation you select. And before you all get frustrated because you can't find Q2, what is Q2 in StatCrunch? Because it's not there. It will be frustrating if you're looking for it and can't find it.
It's the mean or the median, right?
Nailed it. Yes, the median, the second one. Good. Okay.
Okay, but so when I'm looking at I was looking for the 5 numbers, the five summary, but this is 6. So is one number duplicated in this table?
Well, the 5 number summary isn't these. These are 3 of the 5
part
numbers.
of it, but
Yeah.
It's just not an okay.
Yes. This
So
is just 6 numbers we asked you to calculate.
All right.
Nice. Good living, isn't it? Do y'all know where to find them? Can you do it? I'll tell you what.
When I opened mine, it shows that the top with your StatCrunch applets edit, mine are gray, so I can't select any of them.
You got to sign in.
I did. Oh, I guess I didn't. I clicked open another one. Okay.
That's weird. It seems if you signed in one, it should go everywhere else. But
it's
I'm just
a long day already.
It's a Monday. Yeah. And the Red Bull is making you fly, so be careful. You got to come back down to earth.
Okay. Is it a mean of 26.22?
Let me see. Yeah, you got it.
Okay, then I've got it pulled up. Okay, here we go.
Feels good, doesn't it?
Yes, because I've been playing with it. I've been playing with it, and I feel really good about this StatCrunch.
Love it. Love it. StatCrunch is your friend. Love
Oh
StatCrunch.
my gosh. Yes.
I mean, we could maybe call it even more than just a friend, but we won't make those jokes.
I have my best friend did all this kind of stuff in Switzerland, and she did it all by hand. She said, "What do you mean? You just pull it up in a program. I'm like, oh yeah.
He's maybe a little upset right
Yeah, we don't talk about it anymore.
Nice. I have heard tell of at some big four-year universities, there are old school professors that believe there's great value in hand calculations. And so,
and I do too, but this is like too much.
Yeah, right? You click a button and it does it.
It is. Here's I'm not really sure on what still is the standard deviation and that unadjusted standard deviation. If you say standard deviation, is that exactly what you mean? Because sometimes it's not, is it?
So unadjusted is the population version, the population calculation.
So sample is always just standard.
Correct. And how it's written.
So the P is unusual. So the P is unusual, which means P is U unadjusted in my head. Cool.
Okay, that works. It's because it's a different formula between the two calculations. If you know it's a population, you do a slightly different calculation. So in StatCrunch, the way they labeled that is unadjusted is for the population, not unadjusted, so just regular is for the sample.
Right.
Let me give you what? Should I give you 5-10 minutes to finish this worksheet? Do you think you're all good to do the rest, or are you kind of stuck on things? Well, let me let you go work. We'll write these numbers down. I'm assuming everyone has these 6 numbers. If you don't, please let me know and let's talk about it. You need them for the below. Go ahead.
Yeah, Eric, what I was going to suggest is maybe, since Laura didn't watch the notes, is just to give the formula for the lower and the upper fences. So she could do that.
Let me put in the lower, and these formulas, by the way, you have to write down because they're not on any reference sheet. So the lower fence is Q1 minus 1.5 times the IQR. Hence the reason we calculated things up here. And the upper fence is Q3 plus 1.5 times the IQR. Not a huge difference between the two formulas. Easy to screw that up. It's a common mistake. So do what you can to make sure you don't make it.
You guys remember StatCrunch, this is one thing StatCrunch won't find for us. So you have to have these formulas written in your notes.
So let's do 5 minutes and see where you're at. Set a timer for 5 minutes. And don't be afraid to ask questions as you're going. That's what we're here for.
I don't know how you got the Q3 and or not the Q3. The Q3 is on there and the IQR. Or it's the Q2 and the IQR, because I'm not seeing it on my StatCrunch.
Yes, so Q2 is actually the median. And so in StatCrunch, you just have to know that. And
okay.
it's like no one actually ever calls it Q2. We always call it the median, except in the worksheet where we're like, hey, remember how Q2 is median? And of course, the reason we do that is we want you to know that the median is the second quartile, which is also the 50th percentile, which is the exact middle data value of the data set. So it's kind of important that we talk about it, but it's weird that we have three names for the same thing, right? All having slightly different, but also exactly the same information. Did I answer all that, Laura? You said you couldn't find Q2.
IQR's at the very bottom. Oh,
yeah,
no, it's not.
Not quite, close to the bottom. Yeah, it's low. And then don't forget, y'all, because it's a population, we have to use the unadjusted standard deviation. That's why we might have different standard deviations. I'll dump in the wrong standard deviation so you can see. If you had standard deviation, you would have wanted to put 25.8. Did we all, maybe while we're here, why did you all say these were parameters? Like, what was your explanation?
Well, first of all, population.
How did you know it was a population? Oh, because it said
treating these data as a population.
Nailed it. Why is that the correct thing?
Reading the question.
Yes, good. But it just said treat them. It didn't actually say they were.
Yeah, I know, but come on.
Yeah, I'm with you.
Yeah,
this is why. It's all 50 states. So there are no other Superfund sites in America.
Right.
I'm wondering what state has 0 Superfund sites. Maybe we shall go live there. I'd say Utah, but isn't that where they bury the nuclear waste stuff?
See, if we were in a different circle, people might argue what we're saying right now. So,
the Superfund sites.
Yeah, I suppose we should just stick with the population we know.
Oh, got you. Right. So these would be things as reported by the federal government. Certainly we could argue about whether or not that's accurate. What did you all write for Q1? Maybe are we ready to keep talking or not so much? Our 5 minutes are about up.
Let's do it.
All right, let's do it. So what does this 11 mean in context? Nice. Okay, thank you, Misty, for saying you don't know. I love it. That's what I need to hear. Does everyone not know?
Q1 is the first. We're doing a block graph. We're doing a block chart right now.
You're thinking, you can think this in your head. Yep, you can think that. And the 11 is here, and the 36 is here. And oops, nope. That should be 16.5. Yes, we can think about that. I don't know that helps us answer C. Maybe it does. Yes, it does. See, 16.5, 36. So we're supposed to interpret what this means. You know what? I was bad. I didn't read the context here to start, which is what we should always do. So I'm doing a bad job of doing our reading. So let's do that. So the following is a list of the number of hazardous waste sites called Superfund sites due to a 1980 federal law in all of the 50 states of the US in 2022. And then it's been sorted in numerical order. So this is the smallest number, this is the minimum, this is the largest number, it's the maximum. You could click that button and find the source of this information. It's probably some federal website. Okay, so from that, we got that this is a population because it's the 50 states and it's the assumed values for the number of sites in each one of these states. We then calculated the mean, the population standard deviation, Q1, Q2, Q3, IQR. We know these are all called parameters because it's from a population. Brianna's got a great point. P equals population. So that's a great way to keep these memorized. Good. And then we're interpreting Q1. So first we should just be able to write down what Q1 is. It's 11. Well, what does that mean in terms of the context? Well, the context is this is hazardous waste sites, right? And it's hazardous waste sites of all 50 states. And Q1 is the first 25% of the data values. Between Q1 and Q2 is the next 25%. So Peg, this is where I was agreeing with you that the box plot might actually help, or the box and whiskers plot. So if you look back in your reference sheet, there's a sentence structure you can use. And you can say 25% of all states have, you can use the word at least, no, at most 11, or have 11 or less hazardous waste sites. Hazard, how do we spell that? Hazard, oh, there we go. How do y'all feel about that? Does that seem okay?
Could you also say that 75% have more? Or do you want just it would still be okay?
Either one, yeah.
Okay.
So yeah, you could say 75% of all states have more than 11. The key is it can't be equal to 11. So I'm glad that you said more than. Because the quartile, the lower percent can equal it. Equal or below, or less hazardous sites. Awesome. Were you all able to calculate the lower and upper fences?
I had one with a negative value.
Nice.
I don't know if I did it right, but.
You did.
Oh.
Good job.
Awesome. Yay me.
It's the lower fence, right? Negative 43.
Yeah.
That tells us something about the data set, because you're probably like, how can there possibly be negative 43 Superfund sites? Wait, did I do it wrong? No, I think you had negative 26.5. Did I put in the wrong numbers? I did. Isn't the IQR is different? IQR is 25. I'm sorry. Thank you, Emily. Okay, so it should be negative 26.5. And if you're thinking about the context, which you should, you're saying that's not possible. You can't have negative amounts of sites. And what that tells you is this is a skewed data set. And this is a hint at what the skew is. It also tells you there are no lower outliers. There are no unusually low numbers. So good job. Were you all able to list the outliers? This is an important understanding of what the lower and upper fences, how they function. You all get those numbers? $73.5 shows up right here. That's the fence. So, Misty, you're on the right track. 0 isn't an outlier because it isn't below negative 26.5. So it's not a number smaller. But there are more than just, yeah, there we go. So this is the line right here. Good, Misty, good. The line is 73.5. Anything above that number is an outlier based on how we're defining it. So yes, what Reagan says is correct. These 4 values are outliers. The 85, the 90, the 96.
I'm running out of eraser.
Oh no. That's why I always write in pen, so I don't have to erase. Then you also have to never make a mistake, but that doesn't work. Oops. Okay, cool. It's okay. That's part. This is where you want to make mistakes. What'd y'all get for Michigan's Z-score? Did you get 1.518? And did you feel like that was unusual? Actually, we can't use that definition here because this is a skewed data set. If you look at the mean and the median, they are not approximately equal. So really the Z-score is not a useful calculation. Nice, Emily, good job. Not a use. Go ahead.
Sorry, when we see like we do the stuff in StatCrunch and we get our numbers up here, do we always do the third to the third decimal point? Because I only put 25.54 and I got 2.46, and that's like way different. Oh, 3, I didn't see that.
That's the only reason that you are required to give 3 decimal places, is because we told you. And so like if you had shown your work on this, I wouldn't have counted you wrong. I might have counted off a half point somewhere or on the whole paper for not following the directions on this part. But sometimes that's why we give the directions, so it makes it easier to grade. If we all give the same decimal point, when we do the calculation down here, we'll all get the same answer, exact same answer. It being a little bit different doesn't make it wrong. It just means you rounded to a different number. Okay, good. How are we doing? What'd you answer for G? Hazardous waste sites per state. What type of variable? Discrete, continuous, qualitative?
Would it be the quantitative continuous?
So why continuous and not discrete?
Because we're going to continue receiving data about this. It's not something that can just stop.
I like that thought, but you don't want to think about the reception of data, because that's true about everything ever, I think. The continuous versus discrete is focused on when we get the data, what kind of numbers are we getting?
In continuous, there seems to be a whole lot of decimals. And in discrete, there does not seem to be any. So
think about what this is. This is a hazardous waste site. You all are making great points, Regan. That's a good point too. So if we are counting waste sites, how are we going to count them?
By how many there are.
Yeah, so there's like 1 or 2 or 3, or there's none. We're not going to say, oh, there's a 50% waste site. Now, what we could do, we could turn the waste sites into a continuous data set if we looked at, say, the square footage of affected Earth. You know, we're like in Chernobyl, right? There's a certain boundary line where you're walking into a radiated area versus a less radiated area. So if we measured the hazardous waste sites in terms of square miles or square feet, that would be a continuous one. Because as we cleaned it up, presumably the affected area would shrink and we could do all those kinds of measurements. Whereas we're not going to say we have half of a waste site. It's just still a waste site, whether we made it smaller or larger. Hopefully that's helpful, Laura, in the distinction between the two.
Yes, it is. Thank you. Thank you, Peg, for speaking up. I appreciate that.
Sure.
Good. I think I would like to go to, let's see where we at. It's 12:10. I would like to jump to the project, and we'll pause on this. Maybe this would be fun for you to try a little bit. We might have time. Let's go to the project, and then we'll come back to page 3 just in case, because the project is really similar to what we just did. So we're going to go to Canvas. And we are going to go to module day 5. So last week's day. And we're going to click the chapter 3, project 3. And as you may recall, you're going to click this link thing. And then you have to download a Word version of the project that you can actually edit. So I'm clicking on this link. It opens this Google Doc. We're going to do File, Download, Microsoft Word. Look at you all logging in there. Here's an anonymous lemur, and Wolverine, and Camel. There we go. Awesome. You all are making it. Now I'm going to give you 10 minutes to work on this. I think I don't need to read anything. I think you got this, but I could be wrong, and that's totally okay if you need help. You're just doing like we've done in all the other projects, selecting a data set that has a quantitative variable and then finding a bunch of stuff. The one new thing that maybe we haven't done is copying in the output. No, I think we did copy the output in. I'd be more than happy to show it again, but I think maybe you got this. So let me just set a timer. And at any point, if you're finding yourself frustrated, let me know so I can help you. Set a timer for 10 minutes.
Every time you say you're setting a timer, I feel like we're in trouble because that's what I do to my kids.
You've got 5 minutes and we're leaving the store, or I'm spanking your butt and then we're leaving the store. Yeah, no, you're not in trouble. It's for me, not for you. Because if I didn't set a timer, I would start talking in 2 minutes and be like, are you all done yet? Come on, let's do this. Are you done? So no, let me enjoy. Yes, you pick any data set you want that has a quantitative variable. This is the chapter 3, project 3. And it is on the day 4 module.
I think it might be day 5.
It's on the day 5 module. Yes. I picked stocks because that's the thing that came into my head, but you'll pick whatever you want. You could even use the super funds data set if you wanted to.
What was the IQR again?
That is called the interquartile range, and it is one of the options in summary stats. It comes right below the sum.
I'm stuck on the Q3 one now. Well, didn't we just write that down? I have a bunch of sticky notes. That's how I'm managing today. You're muted.
There we go. I said I'm sorry that your day is that exciting. It is the same thing we did for Q1 in the worksheet, except Q3 is the third quartile, meaning it's 75% of the data is at or below that particular number. Was that helpful?
Nope.
Well, time's up. You can get out of timeout now. So Q3 is the third quartile, meaning 75% of your data are equal to that number or below that number. So the context is whatever variable you picked. In my case, I'm looking at stock prices back in May 2014. And so my Q3 happens to be 39.02. So I would be saying 75% of stock prices are, what was this number? 39.02 or less. And then the other way you could say it is 25% of stock prices are greater than $39.02 if you're using my data set. Does that help? Great question, Brianna. So if you go back up here, you need the 5-number summary and then the mean, standard deviation, and variance. So the 5-number summary are, these are the 5 numbers. It's the minimum, Q1, the median, Q3, and the maximum. Those are the 5 numbers in the 5-number summary. And that, if you look at my box plot, those 5 numbers show up on this box plot in that order: minimum, Q1, median, Q3, maximum. And then in this case, because we're doing a sample, you need X bar, S, and S squared. Those are the things that you're supposed to have. Did I have more than that in mine? I don't know if I added more. No, I think I had. Yeah, this is the same one. And then just as a reminder, you had to click inside, like I'm clicking the white space here, and then do Control A, or you could right click and say, can you right click in there? You can't. You could drag so that you're selecting all of that. I just prefer Control A. And then after that, you can right click and do copy and then paste over here, Control V, or right click and paste. And that's how you get that box into the Word document. And you can move it around a little if you want.
Can you tell me how you get that box plot that you just got? Because I'm trying to do my like worksheet and I can't figure out how I get that box plot. Can you walk me through that?
Yeah, you go to graph. And under graph, there's the box plot option. What's the stem and leaf?
Yes. Okay. Okay.
Let me just quick see what this is. Yeah, we don't want that. So box, you good?
Yeah,
Select your
I'm
column.
good.
There is a way to do it horizontally. There it is. If you click this button, draw boxes horizontally. It might be nicer. She suggests that because it gives it that way, but you don't have to.
Okay, thanks.
You are welcome. I don't like that. Oh, that's cool. Other questions y'all have? Is everyone feeling pretty good about this? If you can get the output, these are just like, I don't know, we tell you to calculate the range from this. You could also just have selected it. Same thing here. We're like, hey, find the IQR from your output. Again, you could just calculate that. Let StatCrunch do it for you. It doesn't particularly matter. Let's see, we just showed how to construct a box plot. You are then going to talk about, are there any outliers? And the box plots, if you select the option for outliers to be shown, let me show that. They will show up as dots. This is the maximum. It's also an outlier. I think that's the default selection. It's right here, use fences to identify outliers. What's happening is StatCrunch is calculating the upper and lower fences and then identifying any data values that are outside of them. So it does that for you. There I put in the mean and the median. Let's see, and then it says, what's the shape? I would look back at your notes for 3, 4, based on the shape, like which whisker is longer kind of thing. And then remember, once you know the shape, that tells you what the best measurement of center is and the best measure of spread. Make sure you answer both. And the explanation is just, it's skewed or it's not skewed. That's it. That's how you explain which measure was best. And that's just how we determine it. So my thought is that you all got that. But I want to give you a chance to ask some questions just in case you don't have that. Is anyone stuck anywhere on getting the data, on understanding of how to interpret the data?
So Eric, I just want to point out, they took their first quiz for me this week. And one of the questions, well, 2 of the questions, and some of them got it part right, where it asked what was the best measure of center, and they would say the mean is greater than median. So they would answer correctly and say, you know, it was skewed right, which was perfect. But then it would say, what is the best measure of center? And they would say the mean, because you add them all up and divide by how many. And of course, that goes right along with this right here. Remember, with skewed data, and you guys, this will be your page 107. Works that, remember, I told you this will be summarizing all of chapter 3. If the best measure of center when you have skewed data, remember, is always the median.
Yeah, and when you're answering this question, your options are mean or median. And when you're explaining, you never explain how to calculate these things. It's always, the explanation is always either it's skewed or symmetric. That's your explanation. Let me put it in the order that I listed in there. So if you're going to report the mean as the best measure, it's because you noted that it was a symmetric data set. Go, Regan, talk to me.
So you can tell that it's skewed because the mean is greater than the median, but then you use the median to find the center. Am I right? Or does the mean being more the median not matter right now?
So that mattered because that told you it was skewed
right. But then
it can also be that the mean is less than the median, which tells you it's skewed left. Right. And
but if it's skewed, you just always use the median and mean when it's symmetrical.
That's it. That's the key. So you needed that relationship to know it was skewed, which then told you the median was the correct measure or the best measure. If you look at the shape, and the shape and that relationship between mean and median will be the same. And that's partly what we're trying to get at. Well, here we're just asking you to look at the shape of the box plot to determine it. But you have the mean and the median calculated up here. So for me, I have a mean of 25 and a median of 18. Oh, the mean is bigger. So my box plot is going to show the skewedness, which it does. Notice this whisker is longer. So this is skewed right. It's probably easier to interpret a box plot for skewed or not skewed when it's horizontal. So there you see the right side is longer, making it skewed right. Like if I wanted to draw on this, I can show that it looks something like this. I don't know how to get out of there. But yeah, good question. And that is a very common mistake I see what Cindy's saying that some of you did on the quiz. I see that a lot too on the midterm. Hint, hint. There's going to be a question that says, here's a data set. You're going to calculate a bunch of stuff. And then we're going to say, what's the best measure of center? And lots of times I have lots of students that say that exact thing. The mean, because you add up all the values and divide by how many. Don't fall into that trap. Put a note somewhere on your reference sheet. It's whether or not it's skewed or symmetric. That's how you know. Okay, anything else you all want to ask about this project?
Whether it's skewed or symmetric isn't a shortcut. Just if you know the median and the mean, that's all you really need.
100%. That is the guaranteed best one because you can look at the numbers and compare them.
And that's it.
That's it. That's like, you can't argue that one side looks shorter than the other. Like, because sometimes you could say, well, I think these whiskers look like they're about the same length, so it's symmetric.
Numbers.
But the numbers, I don't want to say they don't lie, but sometimes they're easier to read. This one is very obvious. My example, the right side is way longer than the left side, so definitely skewed right.
You guys also remember that next question that you have on there is what is the best measure of spread? And we talked about that when you have skewed data, median and IQR go together.
Let's see.
Which again, this is all on that summed up nice and neat for you on your page 107. And then remember if it's symmetric data where we use the mean for the center, we use standard deviation for spread. So if you're doing yours right now and you, like Eric, he would be using, since his is skewed right, he would be using the median and the IQR.
Brianna, the intention, I think, of the author of this thing was to make you use the formulas for these calculations for range and the other one. But you can also, yes, I'm totally fine that you just select range and IQR in StatCrunch as an output.
So another mistake I guess I did was on range, Eric, where students were just either giving the max and the min and not doing the subtraction. So this was being graded automatically in StatCrunch. And so they would give maybe a max and obviously it's the wrong answer. So you do need to actually subtract it out and give what that subtraction answer is.
Yes, if you don't have access to StatCrunch and all you have is an output like this, then you need to know the formulas and you have to do the calculation. Which is what we're trying to do. That's why you're like, that's why we told you here, only give these things. Don't find the range in IQR because that's cheating. It's not, but that was the idea. So that to force you to think about how the range and the IQR are calculated. Remember, it's maximum minus minimum for range, and it's Q3 minus Q1 for
IQR.
IQR. Can't think and look and. Cool. Other questions you'll have? Great questions. If you make any mistakes, don't feel bad. This is the time to make them. If we don't have more questions on this, I think what I would like to do for the last 23 minutes of class is take a look at the chapter 3 review, have you get started. Well, let's just glance at it. And I need to remind myself that we want to let you taste it yourself before we put any salt on it or sugar or whatever you prefer. So this is the big review of chapter 3, page 516. And we really, really want you to do all of it with zero help. And then we grade it so you can see what you get. Now, when I say that, I also mean when you get stuck and you're like, I can't do this question, then let's talk about it. But this is a really good review of everything we learned in chapter 3. And it's a really good prep for what you're going to see on the midterm in terms of information from chapter 3. So here is a data set. And you calculate a bunch of stuff. Note things we just did. Think about what that definition means. How do we tell the shape? We just talked about that, right? This measures essential tendency. Man, we were mean. Remind yourself that also means center and then spread. So it's just, to me, it's a fantastic one because you've got your data set, you find a bunch. Go ahead.
Spread also means dispersion too, right? Though, because that's where it is on the notes. It says dispersion. And I think somebody else got thrown off with that on the night class.
Yes. Remember that when we wrote down the like overall notes for this, it was center, average, central tendency mean the same thing.
Yeah. Spread,
dispersion, and variance. Nope, wrong. Yeah. Variability mean the same thing.
Yeah.
So yes, we're super mean because we give 3 words that are all exactly the same thing.
You know, this whole thing, everything. There's a lot of words that mean the same thing.
Yeah, but you know, I was thinking about that.
All right, it's cool. I'm getting it.
But I was thinking about that this morning. Like this first couple units, we're teaching you to talk, right?
Right.
Like when you were a baby, you learned how to talk because you had to. That's how you got food and water, and you learned lots of different names and ways to communicate a particular need. Right. We're doing the same thing here. We're giving you lots of different language and words so that when we start doing stuff, we can all communicate.
Exactly.
It's just a new language, which isn't fun.
It's cool. This is why I'm a lifelong learner. I love learning new languages.
Yes.
So, yeah, it's cool.
Good. Okay, here's a box plot thing. I've seen exam questions very similar to this. So it's reading the box plot. And then remember this mess. I need to apologize because I showed you how to do all of this in StatCrunch, and that was not helpful at all. So please ignore everything I showed you how to do in StatCrunch unless you found it useful. And just remembering how to calculate this and being able to do it. If you're just using a calculator and doing each piece, that's fine. Cindy was like, maybe, because in night class, we did the same problem. And I'm like, should we do this in StatCrunch? And Cindy's like, no, let's not. And it was probably helpful that I didn't. So I'm sorry that you all got to be the guinea pigs and got tested on. But hopefully you're good with all this. I'm thinking, as I look at this, I know we've done every type of problem here. So use this as a quiz thing that tells you whether or not you know it. That's the goal. And then try to get as much of it done for Wednesday so we could start class on Wednesday saying, with questions on this. Again, I know your lives are busy and you may not have time till this weekend to do it. That's fine too. We can talk about it on Monday as well. How about we make sure we finish the 3-4 worksheet though? So I feel like you've got most of this project done. Oh, great question, Laura. It's called Desmos. So it's DESMOS.com. You can download a free app to your phone if you want. It's not as useful because, if you're my age and not super typey tech person, then because you have to type on a phone, right? It works. I use it. It's just not fun. So let's finish this worksheet. I know I'm jumping all over the place. I hope we're okay. This is back to page 510. We've got 18 minutes. So let's say, how about I set the timer for 10 minutes and let you try this? And if you get stuck, we can talk about it, and then we can go over our answers for the last 8 minutes of class and make sure we're all ready for tomorrow and Monday or Wednesday. When we do the exam, the plan, I've never done this, but this is what I've heard other people do. We all log into Zoom, and you set up your camera in such a way that I can see your work area. And then I just sit there and watch you all take the exam.
Eric, I will suggest, I've had instructors do it both ways, but what's worked 100% better is if we place them in separate breakout rooms.
Okay.
Otherwise, it's very, very distracting.
Gotcha.
Like if a student has to ask a question, it's just very, I'm going to just tell you, it's very, gotcha. Very distracting.
Everyone hears it. Yes. We might.
And you can see, like, they will be able to see what other students, I mean, not they won't be able to see their paper. Yeah, you don't have to have it will be muted, but you still have to have your cameras on. So a lot of people said that it's very, very distracting. So if we place them, it's more of a hassle for you and I, Eric, because we have to bounce around from different breakout rooms, but it's fine.
Sure.
And they have their option to raise the hand, like if they need immediate help, that we could go in there. But it's super easy to do, and obviously we want it the easiest on them, right, so that they can feel like I can concentrate.
We could try Big Blue Button, because that one you can create breakout rooms and you can go into every single breakout room at once.
Oh.
And then if you want to talk, you just have to turn on your mic, which takes a few seconds. But that way you can see everyone all at once. We'll see. That might be just too much work, because then we have to learn a new system. And
yeah, exactly.
We'll see.
It's really not a big deal. When you create I mean, I can show you how to create the breakout rooms really easy. Well, you know.
Yeah, we've done it. Yeah.
Yeah, well, you can do it beforehand. You can have the breakout rooms created, right, and then you just place them in there as they come in. It's super easy. If I can do it, you can do it.
Oh, yes.
That's all I gotta say. Me tech not person, you can do it.
Yes. Emily has asked a really good question about posted grades. I discovered that the one assignment I graded yesterday, or like, I don't know, whenever I graded it, the comments didn't save because I didn't know about how the comments are saved. And I haven't done any grading since then. So I am just way behind in grading. So you all aren't missing anything. I'm just not doing a great job with keeping up with my job. So Brianna, would you be willing to ask those now? Because I have to go to a class immediately after this. I'm sure there would be lots of people that would love to hear your questions. Ooh. So I'm sorry, I should have shown that. So IQR is the third quartile minus the first quartile. So you're going to take your numbers that you calculated. Am I muted still? No, I'm not. Okay. You're going to take your numbers that you calculated and do that subtraction. I didn't finish this. So my IQR is 30.44. And my units are dollars. I always forget to put units on things. Does that help, Brianna? You don't have to write this. You can just write the number, but you do have to do a subtraction for that. Cool, good.
Is it possible for my range and my IQR to be the same number?
Ooh, shouldn't be. No,
Okay.
That's not possible. Well, yeah, no, it's not.
Okay.
And here's why. Your range is the difference between the largest number and the smallest number.
Okay.
So they're the extreme ends, and then your interquartile range is the difference between Q3 and Q2. Q3 and Q1. Those two numbers are going to be closer together than your maximum minimum.
Okay, that helps.
Good. Brianna, is that number 1? Yeah, no. Okay, oh, gotcha. Okay. So what this is getting at. So we're looking at the 3.5 worksheet number 1, question F, that says there has long been a charge that Hollywood is biased against older women. And then we're supposed to look at how does this support that? Well, first you have to note that actor tends to be, is a word for male, and actress is female. If you look at the median age for actors, so for the best male person, they're between 40 and 50 for both supporting and best. Whereas for female, the center or the average for that is between 30 and 40 for both. So that's number 1, that's younger. And then if you look at the skew on these, best actress is skewed right, meaning there are far more young best actresses than old best actresses, although there are some outliers here. Same thing for best supporting actress, although this almost looks symmetric. I think it's still a little bit more skewed right. Whereas if you look at the male ones,
can you share your screen?
Is my screen not shared?
Maybe
I can see it. I can see it.
Okay. I can see it, but everyone's face is bigger. And then I have a little one in the corner.
Remember, you need to change your view. Change it to speaker view up in the right-hand corner. Change your view to speaker view.
Okay, got it. Thank you.
You're welcome.
Good. So I don't know, like if we ignore these outliers, best actor looks roughly symmetric. And you can look at the other thing to look at is look at the minimum age for these. Way younger for best and all the rest. So that's Brianna, that's kind of the idea that you're looking at. It appears that the majority of the award, well, that when we award best actress and best supporting actress, they tend to be younger women than older women on average, or the center value. And then for men, they're older. That's one argument. Oh, and this one, interpret the mean and the standard deviation. That's that sentence structure. We expect, and here we're looking at the number of tropical storms per year. So you would say we expect a random sample of, let's see. We expect a randomly selected year to have a mean of whatever the mean is. Let's say it's 10. A mean of 10 tropical storms per year, give or take whatever the standard deviation is, 3 storms per year. So it's that we expect part. The data value is the number of tropical storms for a randomly selected year, with the give or take whatever the standard deviation is. Does that help at all, Brianna, or is that? I guess I could write it. That might actually help a little more.
So you guys, we like how we were using our form, we can expect there to be I can tell you what the numbers are just so that you can make sure that 15.727, that's what you should have got. And what is it, tropical storms? And Eric, you were close, give or take 3.663.
There we go. Nice. Brianna, which part is the lost part? Is it identifying the context? Like what part is it? Is it getting started in general, or what's or is it just that I was speaking it and I should have written it down?
Did you have the numbers from above? Did you get your box, all that box filled in part A? No. That's not a major part of it. So just look at the script that we wrote on the script is on page 78, I think. I say all these numbers in my head, but I think it's right.
Close. Is it 68?
Oh, it might be. I don't know now.
No, not 68. 86? Oh, there it is. 86. It's on page 86. Yes, anytime you see the interpret the mean and standard deviation mess, that's that page 86 script of the we can expect blah, blah, blah. And I think probably the hardest part about that, if you remember the script, the most difficult part about writing the sentence is the context.
Yep.
And there isn't a script we can give for that. And then like trying to get it into nice English sounding a sentence can be challenging too. I won't be picky if how you write the context isn't beautiful sounding or smooth sounding. It's okay if it's a little rough as long as it's the correct variable. If you talked about the mean year, I would have taken off a point because the variable here is not the year. We're selecting a year and we're counting how many storms occurred in that year. So when we randomly select a particular year, we expect the mean number to be this, give or take this. And there was, I don't know if you've been all watching the news, there's Fiona in Puerto Rico that slammed them, destroyed all power everywhere. I might be coming back on, but. Okay, I've got to go to my next class. So just a reminder of what you're doing. We completed this, except we didn't talk about the last page. So we can talk, if you are stuck on that last page, bring those questions to class on Wednesday and we can start there. We did not do this 1-2 worksheet, so maybe we're probably going to just delete it and not have it turned in. The main thing is, do you know the difference between explanatory variables and response variables? And 4.1 and the 4.2 worksheets go great with that. We mentioned that you're working on this chapter 3 review. So get started and treat it like you're taking an exam. And what I mean by that is have your reference materials with you as you're working through it, and look just at your reference materials if you can. That's the practice of what it's going to be like on the midterm. And then we completed, in my mind, the chapter 3, project 3. Again, if you have more questions, don't be afraid to ask as we go through. So where are you all at? Do you feel good? Does anyone have any questions? And then you've got some stat lab that you're looking at, 3, 5, 4, 1, 4, 2, 4, 3. Awesome, Peg. Have a great day. Great work. Don't forget, I am available 8:30 to 11 every morning. Tomorrow I'm in person as well as on campus. So yes, come on in. I am happy to help. And then if you aren't ever available at those times, we could schedule a time to meet if you would like. And then also don't forget that the college has tutors that you can work with as well. You can build a relationship with them and meet with them for, I think, half an hour to hour sessions you can schedule. You can walk into the Center for Student Success, and I think there's on-demand tutoring. I know they're a little short-staffed right now, but I think they typically have someone every day, I think. I'll have to double check. Okay, I am going to take off, and I will see you all on Wednesday.
Sounds good.